morning to all. This is B. REKHA, working as Assistant Professor in EC Department from Tigala Krishna Reddy Engineering College. So, today let us discuss one of the topic from VLSA system design, that is N-well process. So, before going further N-well process, first let us know what is CMOS fabrication. So, the CMOS fabrication is nothing but the combination of NMOS fabrication along with the PMOS fabrication. So here we have different CMOS fabrication techniques such as N-well process, P-well process, Swinter process, silicon on insulator process. So let us discuss about the N-well fabrication process today. So coming to the fabrication process, the first we are taking the pure silicon substrate or pure silicon wafer, which is converted to P substrate by adding of impurities. So here we have trivalent impurities as well as pentavalent impurities to convert either P substrate or N substrate, depending upon the well we are forming. So here we are forming N well, in that we are going with P substrate. Next, we will have the oxidation process. So coming to the oxidation process, it is done by using high purity oxygen and hydrogen, which are exposed to 1000 degrees centigrade. So oxide layer is formed onto the P substrate. And the thickness of the oxide layer is 1 micrometer thickness. And here, while doing the oxidation process, we have two oxidation process. The one is we have dry oxidation as well as wet oxidation process. When coming to the dry oxidation process, we are keeping the silicon wafer into a tube and passing the oxygen gas in order to form oxide layer onto the P substrate. Or else we are passing the water vapor into the tube in order to form silicon oxide, which is also called as wet oxidation process. The next step, we are going with photoresist. So a light sensitive polymer that softens whenever exposed to light is called the photoresist layer. So here we are depositing the photoresist layer to form the uniform thickness over the surface of oxidation. Afterward, followed by the masking. A mask is projected onto the surface of the wafer and the UV rays are passed through the N-well mask in order to form a window in the oxide layer. So the photoresist layer is now removed. A part of the photoresist layer is removed by treating the wafer with a basic or acidic solution. As well as here the windows are formed to form the terminals such as source, drain and gate. So here the SiO2 oxide layer is removed through the open area made by the removal of photoresist using hydrofluoric acid. Next, the entire photoresist layer is stripped off. Next, by using the ion implantation or diffusion process, N-well is formed with the deep thickness of 4 to 5 micrometers onto the substrate. Next, using hydraulic acid, the remaining substrate of SiO2 layer is removed. After that, we are depositing again the polysilicon onto the thin oxide layer by making use of chemical vapor deposition. Now, here Gate terminals are formed both on the substrate as well as on the end well in order to have the connectivity, or in order to have the gate terminal of both NMOS as well as PMOS, and the remaining layer is stripped off. Now the oxidation process again it is followed by making use of oxidation layer onto the surface of the substrate as well as on the terminals. The masking is done and end diffusion is done in order to form the source and drain terminals into the P substrate as well as N well. Next, followed by the removing of oxide layer onto the substrate. Next, similarly, we are forming N plus diffusion both in the P substrate as well as N well. So now the thick field oxide, a thin field oxide is formed in all the regions except the terminals of the PMOS and NMOS. Now the aluminum is deposited onto the substrate by making use of metallization process to have the interconnection between all the terminals. So now the removal of excess metal onto the surface of the substrate. You can see the terminals formed both in the PMOS as well as NMOS. We have total 3 terminals such as source, drain and gate terminals along with the substrate. Thank you.